providing a service and we're the researcher. And we'll tell you about some of the ways we've done research in the past, and maybe it'll help you do it in the future. So really, as I mentioned, manufacturing hasn't been done in space before. So it is a big shift in the way things are done for NASA, for space companies, for new space companies. And three areas I'll talk about because we're doing it right now is building things in space for space. So we have a 3D printer on the International Space Station. And those parts are used by astronauts and researchers on the space station right now. The second is in space for Earth, and this is coming up in a couple months. We're going to build fiber optic fiber in space and take advantage of the microgravity environment to build a better product, bring it back to Earth, and sell the product on Earth. And that's a revolutionary new thing, and something that usually has been limited to data, pictures of the Earth or sensing information. Now it's going to be a physical item that we're going to bring back to Earth. And the third is our Archinaut program, and that's to build essentially larger structures, as Erica mentioned. The researchers and scientists for decades have come up with these great instruments that they'll be able to achieve great things, but they're very, very large, and we want to be able to support that and make those type of equipment. So real quick, this is our 3D printer on the space station right now. It's been there for a little over a year. And a couple things I want to point out. Well, maybe the first that's kind of interesting to some of you is there's a logo on it. It says Lowe's, Home Improvement Store. And that was our kind of our way of drawing in companies that aren't traditionally in space and start getting their money and resources and interest into space and start funding research. And we need to get a lot more of these companies, maybe all the companies on Earth involved in space, to really get to the big vision of living and colonizing space. So this is our one of our steps. We were printing a wrench up there, and they want the wrench and tools that we print up there to come from the Lowe's store in space. So that's the reasoning there. And then the benefit we give to them on Earth is we spin off some of this technology and help drive it into their stores. And so there's a promotional benefit and as well as a technology benefit. Why 3D print in space? I probably don't have to tell you guys, but really it's just getting things there quickly. There's a lot of stuff up there, and we can reduce the amount of stuff into just digital files and raw material instead of spares and backup spares and backup spares. And every reason you need stuff here and you go to the hardware store here on Earth, same reason to have it in space. Really quickly, how do we do it? With our 3D printer, it's pretty easy. We either CAD it up or scan an item here on Earth. We send it digitally to space. A couple hours later, the astronaut takes it out of our printer, and they have the part. It's really that quick, and it's kind of cool. We've been doing it for a couple years now, so it's getting to be a little bit day to day and kind of normal for us. But I try to think back on it, and really we're teleporting these things to the space station in a matter of hours, and it's still really cool. And right now we're doing 3 different plastics, but over the next few years we have a roadmap to get more and more capabilities and materials and technologies up there to build everything you might need. Some stats, and kind of interesting. I talked about bringing in some industry partners. But also we've done student projects, we've had doctors, artists, researchers, lots of engineers, all design parts to be printed in space. So really, as I said at the beginning, we want to make space more accessible, and we're doing it with this. Anyone that wants something in space can come to us, and we'll work to get it up there. And some examples, what are we doing right now that's actually useful and impactful? The top left and the bottom middle are actually designed by doctors, one in Japan and one in Canada. And these they want to be able to support humans on a long duration mission. And so these are parts that they can 3D print on demand and make them custom. And the other big impact for them is they use this as a way to show off their project, but really, in addition to supporting the astronauts, this same technology can be used to support people here on Earth in remote regions and disaster relief areas. So they've created these custom websites and parts that can be 3D printed anywhere on the world or space and help people that need it. The bottom left is pretty cool. It's inside the Bigelow beam module. They have a couple radiation sensors in there, and they're comparing adding additional plastic shielding to shield the radiation. So we're putting out different thickness shields, and they compare it between the baseline, and they'll give information back to Bigelow about whether or not they need more shielding inside their habitat. And the top right one is a cool one. It's from some students in Oakland that designed a game to be played in microgravity. They had talked to an astronaut, and an astronaut wanted something fun to do while he's up there, and so they designed a game. And this is really getting people involved that wouldn't normally be involved, and at a young age. And now they're all heading to college and starting engineering degrees, and one day will be part of the space program. I'll skip some of that, but this is a little bit of kind of the research we're doing ourselves. That's kind of the cool thing about having a 3D printer up there. In addition to supporting other researchers, we can support ourselves, and we're actually doing some printing of new material that kind of has a long roadmap. It's plastic made from sugarcane from our partners at Braskem in Brazil, and it's also recyclable. So next year we're going to be sending a recycling system to space, and this material wasn't previously used as a 3D printing material, but now we've developed it as a 3D printing material. We can recycle it. In the future, when we're on other bodies, we can actually grow sugarcane, turn that into plastic, and we don't need to bring it from home. So kind of a long-term vision that we're working on now. The second big project to talk about is Made in Space fiber optics. So this is the build in space and bring it here on Earth. And this is, like many projects, it started at NASA, and they did the research, the fundamental research, to determine that if you build this Z-band fiber in microgravity, you can create a more pure product. And here on Earth, they have trouble making this product in the quality that they need. But if we can make it at this more pure level, it's 100 times better. And what does 100 times better mean? Two things. One, it can travel farther. So data can travel long distances without repeaters. And so if your infrastructure needed, if you have a big data line. Also, it takes a wider bandwidth, a wider wavelength, band of wavelengths. So you have more bandwidth that you can push through the fiber. So you can send more data over longer distances. That sounds really good, and it is, and there's a demand in the industry for it. So we can actually afford to build this in space and sell it on Earth, and there's a market for it. And the interesting story about this is, on the research side, this isn't funded by NASA. Well, they stopped funding it in the 90s. This is funded internally by Made in Space. We've been able to leverage a lot of the hardware we used for our 3D printer to lower down the cost a bit, and then partner with an expert in this material, and really do this grassroots just from us to show that it works, and then from there we'll figure out how to scale it up and build a whole business and industry out of it. But there's lots of funding sources. There's not too many examples of a company just self-funding a whole experiment in space. But now with cases and the space station being there and the astronauts there willing to work, we can do something like this where we can self-fund a project even as a small company. And this one's really easy too. We build it on the ground, we send it up, the crew plugs it in, it comes back down, and we use the fiber. We like to keep our payloads pretty simple and hands-off. And a couple other things we're doing for the future. I mentioned at the beginning we have a broad vision of building everything you might ever need in space. So that's a lot of work to do, but we are doing a few things and I say future, but we're actually doing it right now. We're demonstrating it on the ground, and we just need to get ready to adapt it for space. The first one is building satellites in space. We're going to print a CubeSat structure on orbit, integrate some electronics, and deploy it from station. And we're having universities design it. For the most part, we like to build the systems and let other people design what they actually need and want. So at this stage, we're having universities design what sort of CubeSat they want, and we're just going to print it and build it for them, and deploy it. And hopefully, this happens in the next year with our partners at NanoRacks. We have a program called Archinaut with NASA to develop a system to build and 3D print and robotically manufacture things in the space environment. And this is where the really large structures come into play. And so this is already underway. We're working on the technology here on the ground to prove it out. Next week it's going in a thermal vac chamber to really test this out. And one of the core technologies is a 3D printer without a bottom. So we can build these trusses that just go kind of infinitely long. It's called ESAM, Extended Structure Additive Manufacturing Machine, which is really cool, especially in space, because you can really just keep going. And the cool part, and you kind of see it in these trusses, is you can optimize it. You can print these trusses and structures in space for the loads they're going to take in the space environment, not for the launch loads. So you send a lot less material, and you can get it a lot further and a lot bigger with by manufacturing there. And other worlds. People aren't there yet, but as soon as they're there, we already have the capabilities and technologies to print landing pads or buildings or chassis of cars or whatever you need when you're there. So we have the technology here on the ground, and we're waiting for a ride to another planet, and we'll keep building these technologies and spin them off here on Earth when we can, which is one of the big goals. So that's kind of my introduction, and really what I wanted to present all this to you is, as researchers, as users of the International Space Station, or satellites, or space, or dreamers for really big projects, how will manufacturing products up there help you in your experiment or your science, and make it more achievable or faster, maybe not 40 years, maybe 20 years. Maybe you forgot something in your experiment when you send it up there, or you want to iterate. You want to, send an experiment and then 2 weeks later do it again, but slightly different, and then 2 weeks later do it again, slightly different. You can build your products up there as you need it. And it is a big shift in thinking and way of doing things. But think about how that would affect your project and your goals and your science if we could kind of give you what you need on demand. And right now we can do plastic in space. We're quickly getting more capabilities, and we need feedback from the people that are using space so that we can develop the right systems at the right times. There's a lot of technology to develop, and we don't want to go off on build the wrong thing for you. So that's kind of my presentation. If anyone has any questions, feel free to ask now or email Matt@MediumSpace.
I bet Apollo 13 would have loved to have your printer on board.
Yeah, one of the first things we did early on, like 5 years ago, we had our very first intern, and we gave him the Apollo 13 example. We pulled it up on YouTube, and we had him design a fix for it. And within a few hours, he had CAD'd a design and was printing out a fix for Apollo 13. It was elegant, with no duct tape and no bags. And no so, exactly that sort of thing.
Yeah, and second, can you salvage all satellites? Material is up there by the ton. You can just salvage and 3D print something from it? Is that
easy? We're looking at all the resources that are up there. The very first thing we see up there that's accessible is the trash on the space station. There's a lot of waste up there, foam and plastic bags. So we're building a recycler to turn that into filament for a 3D printer. And then as asteroid mining companies or companies that want to harvest dead satellites and give us raw materials, those are all resources we would love to have, and we'd probably purchase those from a company that wanted to harvest them.
Okay, sounds great. So, sorry I'm dominating the questions. So please, yes?
So 3D printing small things is understandable, but at what speed can you make hoping to get a large structural element built?
Yeah, speed kind of depends a little bit on resolution and how fine of resolution you need. If you're building a truss, your resolution goes down. You can print a lot faster. If you want something really fine, you can print slow and make it more detailed. So we're definitely working on that, the ability to print faster. But you can also start using something as you're building it. So one of the ideas is space-based solar. If somebody wants that, we can start building it up. And as we're building it, you're starting to get power and using it. And then over time, over a year, it starts getting big enough that it's at full size. So maybe some things you can use along the way as you're building it.
Where is the boundary between making something in space with 3D printing and nanoscience, where your subunits are much, much smaller? Is that a direction in which you see people go?
Like self-replicating nanobot type things?
Biological machines.
Yeah. No, we're definitely looking at that and interested. A lot of what we do is adapt technology here on space and here on Earth and send it to space. So there's a lot of technology we're looking at and watching it develop here on Earth, and once it exists here on Earth, we'll send it up there. But things like bioprinting and electronics printing, that's all in our realm. But we're not going to be the cutting edge of that. We're going to wait to adapt it after bigger companies spend more effort and time developing it. Yeah.
About strategy. So it seems that you're trying to tackle a very broad range of activities.
Yeah.
So it's like Intel doing things that Caterpillar would be doing. At the nano level to the macro scale.
Yeah.
Is that a challenge for you?
Yeah. It's an interesting challenge, technically and as a business. And so we developed our vision and a roadmap. And really what we do is we follow this roadmap and take it step by step. 3D printer, recycler, Archinaut with the larger structures, and just step by step working our way up to all the technologies that we would need. So really it's just breaking it down into small achievable chunks that are profitable along the way, and really working through all the steps. And it is a long-term vision. Luckily, most of us at our company are pretty young, so we have a little bit of time to do a lot of it. But we're also doing a lot of STEM to inspire the next generation, because really they're going to keep it going, and maybe a couple generations from now, we'll really get to the full vision of where we're trying to get to.
So Saswatu, and then 2 more questions. Yeah.
Thank you. Optical fiber is pretty cheap on Earth. So when you're making something in space and sending it back to Earth, how does the economics come into play, and is this for a niche application?
Yeah, so this isn't silica fiber. It's called Z-Bland. It's a specialty fiber that's already kind of high price here on Earth. And so we're starting with that because of that reason. Its selling price is already high. So early on, we can immediately sell kind of small volumes. And we've already developed a kind of business planning case for doing mass production in the future, where we can get the price down to more reasonable levels. But right away, there's this immediate need for niche applications of this high quality fiber at a high price.
Thank you.
So first and second, yeah. So
it's fascinating being able to use sugarcane as a precursor for plastics to 3D print, but obviously that's not something that works in like a window box scale. So if you guys have thought about this, how many tons per year of produced plastic does it make more sense to produce the precursors using photosynthesis than direct chemical synthesis using, say, the Sabatier reaction or something like that?
Yeah, we're looking at all ways of making material. So we're actually looking at all those methods. The sugarcane idea would be great on Mars, where you have land and dirt and water. Something on a space station, you're probably going to bring the material with you and recycle it and reuse it over and over again. You're probably not producing material inside of a module or a habitat. But we're looking at all the waste on station, whether it's trash or other waste, and ways to reuse it and process it and turn it into hard material and hard goods. So we're looking at every single method of everything up there is valuable. Once it's up there, it becomes really valuable, whether it's water or air or the trash, and we want to take advantage of it.
So last question, please.
Yeah, I'd just like to take this opportunity to thank Made in Space as a startup company with a bunch of guys working really hard to get this done. And they support STEM education at all levels. They've supported our Enterprise in Space program, high schools, colleges, etc. I think that's a really good forward-looking statement that you're making, that a lot of companies should look at in terms of making the next generation aware of and educating them for going into your business. But I'd also like to ask, what do you think about Zeblan as the first factory in space? Is that something that it might very well be the very first commercial factory in space?
Yeah, I think that's actually the dream. And I think Jeff Bezos had the best quote there: is use space as an industrial center and keep Earth clean. Zeblan isn't, a very dirty process to make, but still kind of that idea of making things in space and creating an industry of selling that here on Earth. Yeah, if all goes well, it will be.
Looking forward. Okay,
Cool.
so thank you very much.
Thank you.